Hello and welcome to Sana Data Dive. Today we are going to start a new series on data model interview questions. So this is the format of the data model interviews. It will be usually for 45 minutes to 1 hour and we will be presented with a business use case and the questions to solve from the data model we built. So usually they'll be um, looking for how well we are able to understand the business use case and what kind of questions we are asking them to get more details to solve that problem. And also our understanding on dimension tables, fact tables, aggregate tables, and how we are going to do indexing and slowly changing dimensions, normalization techniques. So basically, they'll be looking into these concepts like how well we are able to understand and how well we are able to integrate them as a part of this data model and also our understanding on the relationship between the tables and the tables what we build, the dimensions and the facts, how well we are able to relate all these tables and use them to solve the business use case. Let's start with our first interview problem, data model design for solving a business challenge. And the problem statement is ApparelMart, an online fashion retailer, aims to enhance customer satisfaction and optimize business operations through data driven insights. And the problem statement is they have categorized into five different statements here. And the first one is customer loyalty. So they just want to know how loyal the customer is based on certain scenario here, like to analyze repeat purchases within 30 days after initial apparel purchase, and that helps them to gauge customer loyalty and engagement. And the second one is on the inventory optimization. Third one is margin analysis, customer preferences, and the last one is on the promotional impact. So just on that one, they want to assess the promotion effectiveness pre, during, and post promotion, and that helps them to refine marketing strategies. So this is the problem statement they have provided. After understanding this business use case, we need to come up with relevant questions we should ask the interviewer. And the questions can vary depending upon the use case. But for this use case, uh, let me start with so, who are the targeted audience here? So, the business statement, what we are trying to solve, who will be the end users for that business statement? And I can just say like targeted audience. And the second one is what kind of metrics and KPIs we are looking here. And the third question can be do we need to integrate with any of the existing systems? So if that's the case, if they say yes, we have a certain system there and whatever problem statement we are trying to build and coming up with dimensions and fact tables, we have to integrate with that existing system. Then it's a different thing. Like we need to understand the existing data structure and what are the formats they are using. And depending upon that, we will be tailoring our dimensions and the fact tables for the seamless integration. And another important question will be on the data volume and scaling. And if they say it's a huge volumes of data, then we have to understand what kind of partitions we have to build and what kind of indexes we are trying to build there. So depending upon the answer they give us, like on the data volume and scale, we have to come up with those indexes and partition keys. And another question can be on the regulatory and compliance requirement. And if they are seeing any challenges with the existing data infrastructure, so if that's the case, again, we have to come up with a new kind of model where it has to solve the existing problems what they have, and also on the performance and latency requirements. Some questions related to that, and the last one can be anything they are expecting for the future growth and the expansion plans. If that one is there on their roadmap, we can kind of come up with a kind of dimension and fact tables, which may not be relevant for this use case, but at least we can design that and use that for the later use. So those are the kind of relevant questions we can come up with. So now that we have outlined our business challenges and questions we aim to answer, we have to start building the data model. To effectively analyze our business operations, we have to identify what kind of dimension tables are there and what kind of fact tables we are trying to capture here. And how is that we are going to get that information? So we have to gather that from the requirements they have provided. So when I say requirements, this is all they have provided us, and also, like, from the questions we ask them, we may collect some more information from that requirements. So let's start with whatever information they have provided. What are the dimensions and fact tables we should be able to identify here? I'll start with dimension tables here, dimensions, and I'll put the fact table here. So from the first problem statement, we see like customer loyalty. So we know there should be a customer dimension table. And on the inventory optimization table, we see something like an order table. So I'll just have that order table in the fact. And again, for the order table itself, we can say, like, since this one is having other kind of dimensions like promotions, and also they want to understand in much detail, like, if there are any discount applied. So I would like to keep order table at a very high level. So which probably will contain order ID, customer ID, order date, and total amount. And I'll maintain another order table, like, which I'll call as an order detail table, where I'll have this order detail ID or order ID, product ID, and how many quantity they have ordered, and if there are any discount applied, and if there is any promotion happened, what will be the promotion ID. So I'll maintain all kind of that detailed information in the order detail table rather than in the order table. And again, like, coming up with this kind of design, it depends on the questions they answer here. Like, if the data volume is too huge, then this is the ideal way to keep both order and order details in a separate table. And the other dimensions I can think of here is one is the promotion table here, and the other one is product table, because that's where we see in the order tables, like, what kind of products, depending upon that, they want to increase their promotional strategies. So yeah, so these are the to start with, these are the dimension tables and the fact tables we get from these requirements we gathered. So let's start with the first dimension table, customer. So for the customer dimension table, in crafting our customer table for this business use case, we aim to capture comprehensive customer information for personalized services. So we need to know at a very high level, I can think of customer ID, customer name, email, and his loyalty tier. Like, that one, it helps us to track loyalty program memberships, and obviously customer address, phone number, and something like, we can come up with a membership status, like, which indicates whether the customer is an active member or not. So at a very high level, these are the customer table columns. So I'll just copy this one here. So again, like, depending upon the data volume and scaling, again, we can come up with the customer table in this format. Or if the huge volume of data is coming for the customers on daily basis, we can again take out this address and phone number, and keep that as a separate table there. But for simplicity purpose, I'll just keep them in the same customer table in this example. And the next table, and the next one, we can think on the product. So product table, we can think of on the product ID, and what is the category, like, what is the product category there, some description of that product, and what is the price on that, and how many stock quantities available at this moment, and who is the manufacturer of that product. I'm just coming up with some columns here, which may not be entirely using to solve this problem statement and whatever SQL queries we'll be solving later. But in general, if we can think of like what a product dimension table will consist of, we can keep on adding to that table, and we can discuss with the interviewer, like, if they have any future plans to keep them here, or we can simplify further if they don't need those column names here. So I just came up with that relevant product names here. So I'll just pull this product dimension table here. And the next one is the promotion table. So for promotion table, we can think of a promotion ID and what is the kind of promotion, some description on that, and when did the promotion start? So promotion start date, end date, and what is the discount rate for that particular period, and who are the target audience for that, or the customer segmentation for that. It's not like every customer may not receive that promotion for whatever promotion ID they defined for that period. And what is the promotional type? So example, like, is it a discount or buy one get one free, or is it something like first time customers, they are signing up and they want to give some kind of promotions there, and some conditions related to that promotion. So I just came up with those column names. It may not be relevant, but in general, we can think of those promotion column names here. I'll pull the promotion table here. So these three tables will come under the dimension tables. Now let's start with the fact table. So fact table, I identified two here, order and order detail table. So for the order, we can think of order ID, customer ID, order date, and what is the total amount, and what will be the shipping address there, and a payment method, and the order status. So again, order status can be a separate table on its own, but for simplicity purpose, I'm just using order table or order status in the same order table. So I'll pull up this order fact table here. So if the volume is huge and we want to know exactly the order status, is it like in delivery, or it's completed, or yet in progress. So that kind of order status, we can maintain that in a separate order table. And for the order detail table, we can have order detail ID, order ID, and the product ID, the quantity they have ordered, and if there any discount applied, and the promotion ID there. So this kind of information we can maintain in the order detail table. And if the volume is very low, no need to maintain two different order tables here. So let me pull up the order detail table here. So these are the three dimension tables and two fact tables we have identified here. And after coming up with these dimensions and fact tables, um, usually interviewer will stop us at each and every stage, and they'll be asking a couple of more questions. And the questions can be anything related to, like, let's say, yes, we started with these dimensions and fact tables, and let's say they have huge volumes of data. And what is the customer granularity we are trying to define here? And we can just say, given a potential large volumes of customer data, we can, again, as I said, we can consider aggregating certain attributes to reduce the dimensions here. So for example, we might aggregate a customer address and city or region level instead of storing them in the address table here. This can be further, it can have its own table there. And data types and compressions we can talk of, how efficiently we can use the data types for the attributes, especially for customer ID and loyalty tier, to minimize storage requirements. And additionally, we can talk on leveraging compression techniques like columnar compression to further reduce the storage footprint of the dimension table. So at least if even if interviewer doesn't ask those questions, maybe for one or two tables, if we can come up with that kind of solution, that gives a very good starting point. They'll know how deep we have this kind of knowledge while we are trying to build these dimension models there. And we can talk on the indexing strategy. So creating indexes on the frequently queried attributes, let's say on the customer ID and name, to facilitate fast data retrieved. So we can talk on, B-tree indexes, or whatever kind of indexes we are trying to build there. And if we have much depth knowledge on those topics, we can come up with a strategic solution, what kind of indexes we can build on this customer table, or when we are trying to uh, join this customer table and the order table, what is the most frequent columns we are trying to query. We can try to build index on top of that. And on the partitioning example also, let's take an example on the orders table. let's say we partition the orders table by year to improve the manageability. So when we say having the partition on the year, we can say like, while building this order table, we can have partition on the date. So for 2020, partition on the year. So let's say on 2022, data will be on one partition, 2023 data will be on another partition, and 2024 data will be on partition 3. So we'll know, like whenever we query, like, we want to know something for 2023, it will directly go and hit that partition. And if you can build index on that table, and we know exactly, like, we are querying 2023 table data, and then indexing on certain columns like customer ID and some kind of product information there. That improves the performance rather than just creating the table without any partition. So these are just an examples I'm providing. I'll be doing another episode on just the frequently asked data model questions. So as I mentioned, this will not be a one-way talking in the interview. So the interviewer will be stopping us at each and every stage, asking much more in-depth questions related to why we are choosing, these kind of dimensions and these kind of column names. So we should be able to answer those questions if we have some kind of prior knowledge or some kind of preparation on that. So once we have these dimension tables and fact tables, right? So now we have, like, usually this will be the pattern. So they'll provide us a certain number of questions here where we are supposed to write a SQL queries. So this is these queries, whatever we try to build here, they need not be kind of executed. It's just a pseudocode, and all the columns, whatever we built here, we'll be using those columns here. So let's say we are trying to solve this. How many customers who made their first purchase in the past 6 months have made a subsequent purchase in the following 30 days? And let's say we are trying to solve this SQL problem. And we want to query on, in this case, we will be querying on our customer table and the order table. And let's say we don't have an example order date there. We forgot to add an order date on the order table. So we can go back and, let's say, because we need to know exactly the order date to solve that SQL statement, we can go back and or add a order date to the order table. Of course, order date is a very um, essential column which we'll not forget, but I'm just giving this as an example. We can always go back and add our columns to the data model here, because this is kind of, we are building them on the fly, and there are many chances we'll miss the column names there. So that's an acceptable, but important attributes, like let's say we are missing customer ID in customer table, that's not an acceptable scenario. This is just an example I'm providing. So let's try to solve these SQL questions here. So the first question we have here is, how many customers who made their first purchase in the past 6 months have made a subsequent purchase in the following 30 days? So we need to know, I'll start with the first statement here. So now we need to know which tables we have to query here. So how many customers they mentioned. So we need to query customer table, and who made their first purchase. So that should be an order table. We need to know, are we going to use order table or order detail table here? Since they just want to know the first purchase, we can just use the order table where we have the order date here. So let's start with first SQL query. So the first thing is we need to identify the customers who made their first purchase in the past 6 months by selecting the minimum order date of the each customer. Let's start with that one. So I'll say select customer ID, and a minimum order date. I'll just say this one as first purchase date from orders. And I have to do a group by on customer ID. And here the condition will be having minimum order date should be greater than, they made who made first purchase in past 6 months, so that should be greater than current date minus I'm just in an interval of 6 months here. So this one, it gives us the customer information who made their first purchase by selecting the minimum order date of that customer, and then having this condition greater than current date minus 6 months. So that gives us for the past 6 months who made the first purchase. So I'll just keep this one as with, I'll call this as first purchase here. And now what we have to do is we have to just join this first purchase table with our orders table to get the count there. So I'll just start with I'll just say select count of distinct. I'll call this as first purchase customer ID. And do a inner join on orders table on customer table on customer ID. So that gives us the information on the customer ID. And here the condition I should check is where order date from our orders table should be between our minimum or the first purchase. So first purchase this date here. So I'll copy this one and this one plus 30 days. So this should solve the first SQL statement here. And the second SQL statement is which products are below their reorder level at the end of each month and by how much, considering average monthly sales rate. So first we have to calculate the average sales per month for each product over last year. Let's start with that SQL. I'll say I'll select the product ID and count star divided by 12. Here I can directly take the average, but let's assume a case where sales didn't happen in that particular month, but still we have to take the average for each month. So I'm not directly calculating the average here. Instead, I'll take the account star divided by 12, and I'll take this one as sales per month, and later I'll calculate the average from order details. Inner join on orders. O order date is in. So this will be between current date minus interval of 1 year and current date, and group by product ID, and then order date will be order. So no need to maintain any alias here because order date is in order table and product ID is in product table. So that will be group by product. So now we have the average sales per month for each product over last 1 year. I'll just put Now I have to calculate the average. So I'll just say select product ID, average of sales per month as average sales, and do a group by on product ID. I'll just keep this one as average sales, city table here. And now I need to join with the product table to retrieve the product ID. Select product ID from product table. And the question is which product. So I have the product ID, which are below the reorder level at each month and by how much. So since they asked by how much, we need to have this average sales minus stock quantity. I'll call this one as below and do an inner join with our city table. And the condition is stock quantity is less than the average. It's not average sales, it's average quantity. Or in other way, it's a sales. Sales happened for that one. I'll just keep this one as average quantity. Yeah. So basically, we are trying to get the average sales per month for each product over the last 1 year, and then joining it back with the product table based on the product ID. And the condition we are checking is the stock quantity is less than the average quantity. That should solve the second query here. Let's start with the third one. And the third question is, what is the profit margin per product per product category after accounting for average discounts applied in transactions over last year? So we have to calculate the total profit for each product category and then subtract that one with the discount applied. Then we'll get the product or the for each product we'll get the profit margin. So this seems to be a very straightforward. Let's start selecting. They want the product category, so select product category. And we have from order details we'll get the quantity. So I'll just say quantity times price minus we have this discount applied. So this gives us the quantity times price minus discount applied, and we need to find the product margin. So that will be divided by, I need to have this sum here. So I'll get the entire profit by subtracting the discount applied, and the same thing without the discount. So that will be sum of quantity times price. I'll just call this as profit margin. And let's join all the tables here. So we have this product category from product table, quantity from order details table, and price from the again order details table. And the only condition I need to check is which applied over last year. So that should be again joined to the order table to get the order date. So let's start with order details and then do a inner join. I'll just call this as OD. So I joined all the three tables. Now only condition I need to check is where order date between current date minus interval of 1 year and current date. So that should, and since we have this sum here, let me do a group by product category. So that should give us the profit margin per product category in the last 1 year after accounting the average discounts applied in that transaction. Statement is which product types are most likely to lead to a repeat purchase by same customer within an year. So within an year, if we can get the count of the product categories on the customer ID level, and if that count is greater than 1, that means that customer is making a repeat purchase for that product category. So let's start with customer ID. So O dot customer ID and product category. And do one more inner join on product table on product ID from product and order details product ID to get the product category. And the condition we need to check is order date between current date and 1 year. So basically this will give us 1 year time interval and do a group by on customer and category. And the condition we need to check here is they should be greater than 1 to know it's a repeated purchase. And then do an order by, I'll just say repeat purchase descending. So that should give us the product type purchased by the customer. If it is greater than 1, that's a repeat purchase. Let's look into the last SQL query. I'll copy this one. Compare the weekly average sales volume before, during, and after a promotion for each product to measure the lift and longevity of the promotion's impact. So we need to find out how the sales were before the promotion, during the promotion, and after the promotion. So let's start with the product and promotion. So let's start with select product ID from the order detail, product ID, And from this time, I'm joining the promotion table also to get the promotion ID. And let's have couple of case statements to mention like during, before, during, and after. So that will be case when order date is between our promotion start date and end date. That should be during. When order date less than start date, then before, else after. I'll just call this as promotion period. And we need to extract the weekly average sales. So I'll extract the week from order date. This gives us week number. And I'll just do a count star as sales count. I need to join all the tables here. So from order details, I'll start with order details. Do a inner join on orders. And we need to do a left join on promotions because not every product will be having promotion, but we need to find out all the product information. So do a left join on promotion. I'll call this one as P here. Join with the order detail table for the promotion ID and do a group by on product ID, promotion ID, and the week number. So this should give us during, before, and after promotions and the sale count. Let's put this one in a city. Let's call this one as with promotion sales. I'll just call this one as promotion sales, prom sales. And we need to just put together the product ID, a week number, and what will be the sum of sales during each period here, during, before, and after. So let's start with select product ID, week number, and let's say sum of case when promotion period is equal to, let's start with before. And similarly for the other two, I'll just copy this one. From this table, the CDE table, which we created. and do a group by on product and week number. Just say order by. Yeah, this seems to be a big query, but when compared to the other queries, this is very easy and straightforward. So this will be the solution for our fifth query. Yeah, this seems to be a very long session here. Usually in real interviews, they will provide us like the business case statement as well as the queries we are supposed to solve. Depending upon the time and the questions the interviewer will be asking, it's hardly um, unlikely we are going to solve all the five problems here, but at least we need to give an attempt, at least fourth or fifth by the time we reach this fourth or fifth query. Even though we are not able to write the pseudocode, at least we should be able to explain what is that we'll be doing there. Because given the time, just 45 minutes to 1 hour, by the time we come up with uh, the questions, relevant questions, dimensions, facts, and all the relevant columns in that, and start with our SQL queries along with answering interviewer questions. It's very like a challenging task for us in that 1 hour time period. So it's best for us to prepare like the hard um, category questions. Then it will be easy for us to answer the medium or on easy level questions. Hope this session is useful to you. And please let me know in the comment section if you have any other related questions regarding the data model. Thank you for watching this video.